So yes, we just have to accept. So I have added here the equipment ID, and when I create this, we'll have block on the rightmost column. As you can see, this output is a safety rated output for contactors K1 and K2. So you have one, let's say, input, one output, and you have also a feedback loop. So let's see how it works. Now, you need some logic here between the input and the output element, right? So you could have program that would work like this. I just connect the block here from the e-stop directly to the output block. So that means whenever I have those two, the input one, IM0 and IM1, whenever their let's say their logic level is high, and I have reset the button, then I have a high logic level here, and the high level logic level here will trigger our output. But not only that, it's also necessary to have the feedback loop. So the feedback loop you can create from a regular input. So one way of creating that is by, when I go here, I click twice in one of those circles, and it opens a window here, and then you can define what is the input that you'll use for the feedback loop. So let's say I will use I4, and no test poles, no detection of short circuits. Okay, and then I can also add ID for that. So I'll add feedback loop. Okay, let's say K1/K2. It's kind of long, but yeah, when I click on OK, you can see that it has created the feedback loop input here. So what you have to do is to physically connect the feedback loop to the 24 volts, and the feedback loop will go to this side of the output, and now you have connected. Okay, so whenever I have 24 volts here, so my feedback loop will send a signal to the PLC saying you have a 24 volt signal here. Okay, so problem is if you have 24 volts all the time, at some point this will time out, because the normally closed contact is supposed to get open when you have a 24 volts here. So if you have 24 volts here and 24 volts here, something is not right. Then after, I guess, 3 seconds, it will time out, and it will send fault message to the unit. So this is a very simple program that you can have. You could add more functions. So whenever you click on a connection, and the connection gets yellow, you can just delete, and the connection will be erased. It's the same here. I click on a connection, the connection in yellow. When I click on delete, it deletes the connection. Now I could have more elements. So let's say I could use a safety gate. So I could drag and drop. If I try to drop the input element in the rightmost column, as you can see, it doesn't allow me because the rightmost column is for output elements only. The leftmost column is for inputs. And then in this column, in this row, I'm not able to drop the safety gate block because we already have one input here. So I need a whole block like this, so I have to drop it here. So now when I have the safety gate, very similar to the emergency stop, I need to define what kind of safety gate do I have. So I have single channel, double channel with normally closed and normally open elements, double channel with normally closed, normally open elements, and simultaneity. Double channel with two normally closed contacts, double channel with two normally closed contacts, and simultaneity. But you may also have other kinds. But yeah, this would be okay. Most of the times you have dual channel safety gates, but it depends essentially on your wiring again. So, okay, I have selected type 3. Now I should define again the inputs that I will use. So I could say, okay, I'll use I5 and I6. Okay. If I need test pulses, I could use test pulses. So again, it depends on the architecture. I'm not going over this. If you need more information, you can go to the help file. So again, I could define the reset. So let's say again, monitor reset, and I could use the very same reset that I have used before, IM2. So that will be for reset, right? And I don't want any detection of shorts between contacts. And I will also, if I wish, I could add the identifier of the safety gate. So let's say SG1. Whenever I click on OK, this is what I get. This is what I get. I get the SG1 block. So if I click twice here, let's say over here, I can also add some identification for that connection point. So that could be used for reset. So when I click on OK, you can see there's a reset here. And it appears reset over here too, because it's essentially the same point. Okay. So I have one reset button. This reset button is resetting both my e-stop and my safety gate at the same time. But you could say, well, I don't really need a reset for my e-stop, so I could go back here and just define as automatic start, and there you go. You just don't need a reset. It's automatic reset. Okay, now you have two different elements, right? And you could use, like for instance, logic element. I could use AND gate. So I have here AND gate. I'm dragging it to the middle. If I try to drag on the output side or in the input side, it doesn't allow me. You should only add logic elements in the middle columns. So I will add here AND. So I have, let's say, two inputs. I could add more inputs if I need, but I will only use two by now. And yeah, I could add some identification for the block as well. I could also negate some of the inputs if I wish. So I could negate input 1, so it's only gonna work when I have low logic level. But in this case, I'm not gonna use that functionality. So here I have the and logic block. So I add over here, and I add connection, add the connection from here to here. So this means when this block has high logic level and this block has high logic level, I will get a high logic level here in the output. Okay, I could connect this directly here, but let's say I also have a start button. So I could also have a stop button, but I'm not going over that. Again, you have a button function. The only thing of a button function is that if you use the button function, it will occupy one whole block, as you can see. So I have normally closed. That would work with stop button, but for, let's say, a start button should be normally open, right? And I can define what is the input that I will use. So let's say I7. As you can see, you have a whole block. So it will occupy a whole block just for one button. So I don't really want to use that block. I could instead just click twice. So let me just change this. I drag over here. I drag this over here. Okay. Now it becomes a little bit more clear. Okay. I'm just rearranging the blocks. All right, so if I want to create, let's say I have signal from button, I can also just click twice here and define the input, let's say I7. Okay. I don't have any detection of shorts between contacts. I'm not negating. So I could just say, well, this will be working for my start function. Okay, start. Great. I could also have another one, let's say I8, and I will use as a stop signal. All right, so yeah, I have start signal, stop signal, and everything you see in yellow here is safety rated. Okay, now if whenever I use, let's say IM16 as output, this is an input, but let's say here, whenever I use this is for the loop. Whenever I use, let's see, the output, it's a single output, let's say, and it's for standard function. So let's say we'll use IM3 as a standard function. As you can see, it will be green. So green means standard function, and yellow means safety related function. Okay, so it's very important that you notice the colors green and yellow in a software. Anyway, just that was just demonstration. So okay, now I have a start, I have a stop function, and I have end function here. What else should I use? Oh, so let's say whenever I press stop, I also want to stop my output, right? So I can add another input. Okay. And so if I click the stop, so whenever my stop, you have let's say, because typically the stop button will be normally closed. So whenever you open, that means when you have 0 volts in your stop, then you are sending a signal to stop. So if I have 0 here, 0 here, and 0 here, then I will, or if I have in either of these inputs I have 0, I will have a 0 on the output, right? So, okay, but it's not only that. The only way of starting the output function is by clicking on the start function. So you could use, for that purpose, you could use the element start. So whenever I use the start element, so it's sort of a latch. So let's say start latch. Okay. So I could also have different kinds. I'm using monitor reset. So here how it goes. So I send a signal from the logic input here, the logic end. And in order to have a high logic level on the output here, I need my start button to be activated. Okay, the feedback loop here, let me just drag this over here. So my feedback loop here, it will be connected to the output. And then I can connect the output of my start latch. So this is how it works. Whenever I press the emergency stop button, this will be 0 and 0. Therefore, this will be 0. And when I have a 0 signal here, this will be 0 and this will be 0. So I press the emergency stop button. What happens? The output, the safety output, will be off. Okay, let's say I have disengaged the emergency stop button. It will go on high logic level again. Okay, so I have 1 here, 1 here, 1 here, I have 1 here. But the problem is that because you have a transition, you had a transition from 1 to 0 over here, it requires that you send a signal to start again. So this is what the latch will do. It needs a transition to send a signal to your output. Okay. It's the same here. If I open my gate, it will be 0 here, and when I have 0 logic level here, I will have 0 logic level on the output side, and then I will turn off my output. So this is a very simple programming, okay, that you can use. Of course, you could put more. You could put more elements here. The idea is not to show you an advanced demonstration here. It's just to show you the basics. So whenever you finished your program, one very important part of a program is to save the program. So you can either click on save on the save icon, or you could click on project and save or save as. Whenever, since I have an untitled project, that means this project hasn't been saved before. Whenever I click on save, it will ask me to create a password level. So you have level 1, 2, and 3. What are those levels? So level 1 will give you full access for writing program and reading the program. So you can, with level 1 access, you could do whatever you want. Level 2 access will give you, let's say, maintenance level. So you're able to to see what's going on in the unit, to see the programming, but you're not able to edit the program. You're not able to change the programming. So that's level 2. And then you have level 3, which you can have some diagnostics from the unit, but you cannot see the programming and you cannot change anything. So those are the 3 levels. There are more information regarding the access levels. If you need more information, just let me know. So typically what we use is for level 1, we use the password would be 1. But you could change the password for the password you need. It depends on you. So it's a good idea to protect with a good password your programming, because then you will avoid that anybody will have access to your programming, because we're talking about the safety related programming. So level 2 we define as 2, and level 3 we define as 3. Okay, so I click on OK. It asks me to define the password or the name of the file. So let's say I will call this as a demo. So demo, and I can browse and select where I would like to have this project saved. So if I go to, let's say, desktop, yeah, I could save on a desktop. It doesn't matter where I save. So just click on OK. Now it's generating the necessary files, and yeah, so you have a program here, and of course that in this demonstration here, I'm not able to show you with the unit running, because I don't have the hardware here. As you can see, this is just about programming. Okay, but yeah, if you want to go online with the unit, you should, in order to download this program to the unit you have selected, you have to click on the icon Go Online. Now, of course, it will depend on the kind of connection that you have with your base unit. So sometimes you may have a serial connection with the generation 1. You may have Ethernet connection. You may have USB connection. It depends on your hardware. So whenever you click online to go online, you will have selection of ports that you can connect. So in this case, I don't have any system connected to my computer, so yeah, I don't do anything in this case. I don't go online, and I'm not able to download the program to the ship card. So there's some hardware that you use, sort of looks like pretty much like a SIM card. It's a chip card, and you have to purchase the SIM card with us. And some other situations you may have, like for instance the PNOZmulti MB1 version of the hardware. You will click on Project Manager, so you can download the program to the unit. You could also, for that particular base unit, the MB1, you can also use the front USB drive to save the project directly to the USB stick. So you use the USB stick to save a programming in your unit. So of course it will depend on what hardware you have. But that's pretty much it. There are other interesting functions, like I can debug what's going on here. So there's this bug icon here. So it allows me to simulate what I have done here. So whenever I click on a bug, yes, this is the information you have on the bottom of the screen regarding the simulation. So in order for the simulation to happen, to start happening, I need to click on play. So as you can see, the green here means a high logic level. And when you don't have this green or this very light green color on the inputs or on the outputs, it means there are no energy there. There's 0 volts. So let's have a look. So when I click on play, what's happening here? So we can see that the emergency stop is 1 and 1 logic level, so high logic level on the input side. On the output side is high logic level as well, because we have this in automatic startup. Now, if I had a monitored reset, then it would probably ask me for a reset. So here is the case with the safety gate SG1. So whenever I click on the reset button, that would be 820 IM2. So when I force 24 volts here, and remember, it only accepts the transition from high logic level to low logic level. So I need to release, and then I have 24 volts here in this output. So I have 1, 1, and 0. So 1, 1, and 0 will give us 0. So if I have a start button and I force 24 volts here, and again, you need a transition from high to low. When I have a transition from high to low, nothing is going to happen because I still need a high voltage level here. So the stop button should be on high voltage level. So now I have high voltage level here, and now I can latch my start. How do I latch my start? By switching the start button here. When I switch the start button here, and there's a transition from high to low, then I have power to my outputs. Okay. Again, I mentioned that if you have a feedback loop connected all the time, that means in 24 volts all the time, this is what's going to happen. You have 24 volts here, 24 volts here, and nothing happens here. You have timed out your connection because it was supposed to be to have a feedback loop open and not closed. So for that purpose, what I have to do is to reset the system. So I click on the emergency stop, for instance, and put it to work again, and reset. So when I click on reset, and when I click on start, I have my output working again. Okay. Now, of course, it didn't work here on the output side because I don't have my normally closed working properly because I don't have signals. But yeah. You could just stop the simulation, for instance, and create a different output block. So instead of having the feedback loop, I'm not going to work with the feedback loop. So let's click twice here. Now, of course, that in order to change anything, I need to go out of the simulation module. And then I can define if I need a feedback loop. So in this case, let's say, oh, I don't need a feedback loop. Okay. So now I'm able to work with that. So let me go to the debug function. So you have 1 here, you have 0 here. It requires, okay, I have to click on play first. I have to click on reset to reset the gate. So when there's a transition from high logic level to low logic level, it will generate a 1 here. So I have 1, 1, and 1. That means I allow my startlet to work. So whenever I have a reset from the start latch, the start button, it will latches my output, as you can see. And now it appears green on the output side. So this is a very simple programming that was created for instruction purposes of a PNOZmulti configurator. I hope you have enjoyed the presentation, and if you have further questions regarding PNOZmulti Configurator, if you wish to have advanced workshop on that, or a more detailed workshop on that, you can send an email to j as John .vas is Victor Alpha Zulu at Pilz, it's P as Papa, I as India, L as Lima, Z as Zulu .ca. So you send an email to j.vas at pilz.ca, and you will indicate that you need training or support on PNOZmulti Configurator. Thank you very much, and have a good weekend.